This is going to be a quick video to teach the tangent ratio, for how we use the tangent ratio for investigating triangles, for investigating right triangles. The Greeks found that they could determine the measure, or how many degrees an angle was in a right triangle, by dividing the lengths of different sides. They didn't have a protractor yet, so when they were drawing these triangles, they found that if we had a small triangle, 10 centimeters on this side, 7 centimeters on this side, they knew it was a 35-degree triangle. Then if we had a big triangle, like 80 kilometers by 56 kilometers, that also had 35 degrees, then that would give us, if we compared this, 7 divided by 10 is 0.7, and 56 divided by 80 is also 0.7. So if we had another triangle with a similar two sides that were, let's say, 10 and 7, or let's go with 20 and 14. 14 divided by 20 is 0.7. So they knew that this triangle must be 35 degrees. So by dividing these two sides, they were able to figure out the angle of the triangles. The first thing they had to do was give the triangle sides some names. And the names that they came up with were hypotenuse, which we already know, and then the other two sides, we call them in English, are opposite and adjacent. And these names are given relative to the angle we're trying to figure out, or the angle we're working with. So this Greek letter theta, I'm going to try and use the word angle as much as possible, but this determines which angle we're talking about. So we're talking about angle R at this time. If we wanted to name the three sides, this one is the hypotenuse. The same as before. The hypotenuse is the longest side, sometimes it's called the hype. The hypotenuse is always the longest side. That doesn't change. But if this is our angle, that means that the side across from the angle is our opposite, and the side touching our angle is our adjacent. Adjacent is a word that means beside or touching, and opposite is the opposite. So we can name the three sides of our triangle, and that's going to be useful because every single time on our first question, we always did opposite over adjacent. This was opposite over adjacent. This was opposite over adjacent. And this was opposite over adjacent. And so if we want to find this 0.7 ratio for a 35-degree angle, we'd always have to do opposite over adjacent. So to practice that, here we have the same triangle. If this is our angle, which leg is opposite to the angle? That's going to be TS. The leg adjacent is RS, and the hypotenuse is always the longest side. It's always the side across. It's TR. Looking at another triangle, we're talking about this angle. So I'm going to do the hypotenuse first because it's always the longest side. It's always across. This is AC, but in this one it's asking us for the length, so that is 37. The adjacent leg, if this is our angle, this is the hypotenuse, that means this must be the adjacent, AB, which is 35. And that means finally our opposite must be BC, which is 12. And let's check. That is across from our angle. BC is 12. So this is how we name the sides. And if we name them, we can put them into this relationship. When they were looking at it, they were dealing a lot with circles. It works with triangles as well, but that is why this is called the tangent ratio, or the tan ratio, and that's where this word tan is in here for. It means that we're looking at the tangent ratio, and that is always equal to the opposite side divided by the adjacent side. So this is the formula that we're going to use for this whole lesson. Finding the tangent of an angle is equal to the opposite over the adjacent. So what does that look like? If we have a triangle, let's say we're building a ramp. We have 11.5 feet on the bottom, 9 feet up, and we want to find the angle. So we want to find the tangent of an angle. The opposite is, if this is our angle, oopsie, that means 9 is our opposite and 11.5 is our adjacent. So we're going to have 9 divided by 11.5. I'm going to use my calculator here. 9 divided by 11.5 equals decimal 782. Well, decimal 782, so what is this angle? if I would go back and look here, if I got 0.7, I'd expect it to be about 35 degrees. But decimal 78 is a little bit more, so my angle is probably a little bit more. And what we can do is we'll use a table. So the Greeks figured this out, so they made a table of all the different triangles. And it looks kind of like this. In this column, we have all of, oh, I can't draw on this. In this column, we have all of the different possible angles from 0 to 45, and then over here we have from 45 to 90. So they've made all of the possible angles, and then we have sine, cosine, which we're going to look at in the next lesson. But for this lesson, we're just talking about the tangent ratio. So this is the angle, and this is the tangent ratio. From before, we said 0.7. So if we look right here, if we have a ratio of 0.7, that's a triangle of 35 degrees. So I looked up 0.7. So, sorry, when I had an angle of 35 degrees, that means my tangent ratio is 0.7. For the one we had, we need decimal 782. So we search for the number closest to decimal 782, which is this one, decimal 7813. So this angle is 38 degrees. So the tan of our angle equals decimal 0.782. So our angle equals 38 degrees. What is the top angle of this triangle? Well, the tangent of the angle is opposite over adjacent. 29 is our opposite. Our adjacent is 35. So what is 29 divided by 35? Decimal 82. 0.828. All we do is we just go look up what is the angle that gives us decimal 828. 828, that's about a 40 degree. This is the closest one. What happens if we wanted to instead find the bottom angle? So now we're going to be not finding this angle. We're going to deal with the same triangle, but let's find the bottom angle. So it's going to look almost the same, but now the opposite and the adjacent have flipped. So this is something that changes when we're talking about the triangle, is which the opposite and adjacent is depends on which angle we're looking at. Because now we're looking for this angle. We found this one to be 40 degrees. But if we're looking for this angle, the opposite is now 35 and the adjacent is 29. So the opposite and the adjacent is not 0.8 anymore, but 35 divided by 29, and that is 1.2. So now our angle, the tangent of the angle is 1.2 because the opposite is 35 and the adjacent is 29. Oh, I just realized I did this whole question without you seeing it. So I've changed it from the top angle, which was up here, to the bottom angle, which is down here. And that means that the adjacent is no longer 35 degrees because I'm not talking about this angle anymore. I want to find this one. So if we're talking about this angle, the opposite is 35 and the adjacent is 29. So opposite over adjacent is 35 over 29 for 1.2. Now we'll go back to the chart. When we search for 1.2, we can see that it's an angle that's more than 45 degrees because all of the 45 degree angles are less than 1. 1.2 is pretty close to here, 50 degrees. 50 degrees. The other thing that we can remember is if this angle is 50 and this angle is 40 and this angle is 90, all together 40 plus 50 plus 90 equals 180, which is good because that confirms that every angle in a triangle is 180, something you may have learned in previous years, but a useful way to check your work when we're finding the angles in triangles is all angles add to 180 in a triangle. Again, you can't see what I'm doing. All the angles add to 180 in a triangle. So we found this one was 50, this one was 40, and this one we know is 90. So 50 plus 40 plus 90 is 180. So that checks out. This is how we show our work here. We found that the tangent was 1.2, so we knew the angle had to be 50. The last thing we can do, this is the second lesson, is we can find the length of sides of these triangles. If we know that one angle, we can find what the ratio should be, and then we can find the lengths of some sides. So for example, in this one, we would like to know how, that's not a question mark, how tall is this side? And we know that it's a 30-degree triangle and that the base is 12. So we're going to fill in the same thing, except now we don't put in the word angle because we know it. And the opposite over the adjacent, opposite is S and adjacent is 12. So it's a 30-degree triangle, so we know what that ratio is. We can look it up. If we go to our chart, 30 degrees, the ratio should be 5774. So this should equal 5774, and this is S over 12. So we need to determine what value of S will give us the right ratio, or we need to think about solving this triangle. Multiply both sides by 12. S divided by 12 multiplied by 12 goes away. So S is equal to 12 times decimal 5774. I use my calculator, which is about 6.9. So now we know the angle, so we need to find the side length that makes the ratio true. We need to find the correct side length so that this 30-degree angle has the right ratio. If we have this triangle, we want to find the length y. The tan, here we have our angle. We're going to talk about this one as 56 degrees. The opposite is y, and the adjacent is 50. So we need to solve this triangle. The tangent of 56 is 1.4826. So we need it to equal 1.4826. What y value will give us 1.4826? Multiply both sides by 50. So y is going to equal to 50 times 1.4826, 74.13. Let's do one more and call it a day. We need to find the length x here. So following the same process, our angle is 20 degrees. Our opposite, this time we know our opposite is 8, our adjacent is x. So we need to find what value of x will give us a tangent of 20 degrees. Looking at 20.3640. So we need to solve this equation. Do not multiply 8 times 0.36 here. It is the rhythm we get into. It's the easier way to solve these questions. But in looking at our triangle, we can see that a needs to be more than x. Or sorry, x needs to be more than 8. In looking at this triangle, this line is much longer than this line. So if we go 8 times 0.3, we're going to get a number that is too short. To solve this, there's a bunch of ways. The quickest way is we can remember cross multiplying.
Two back pages of this.
Well, Nathan, I'm in the middle of a video, so I'll have to do that later.
Nathan, that's in the video, remember?
If we do cross multiplying, this is 1 times 8 on this side, and this is x times decimal 3640. Now this is an equation we can solve, and what we end up doing is 3640 and decimal 3640. So it's not 8 times by 0.36, it's 8 divided by 0.36. So x is going to be more because 8 divided by 0.364 is 22. About 21.97. So it's 22. And this is the book that my son wanted to show you. Hyrule Warriors in Kindergarten by him. And there's a bunch of good drawings of all the different characters from Hyrule Warriors that he's been playing. Hope you get this. If you have questions, email me.